I can do that. Oh, look at all these people. Good morning, all of you. I'm going to back this up a little bit.
Yeah, of course I won't. Don't get anything.
All right. I see some of you are already on making comments. So actually, Kyler, I do not want that quite that close.
See, can I get any closer?
Kyler.
Yes, I can.
Oh, it's good.
That's as far as
All right. I'm so glad to have help this morning. Looks like everybody, we're getting on there. I have 11 people who are watching right now. So I'll give you guys a few minutes. Looks like you were already chatting about breakfast. So once we actually get started today, I'm going to have you guys kind of keep the comments of non-chemistry to the minimum. Okay, so chat before we get started about your breakfast. I am kind of curious how many of you are actually in your pajamas this morning during our class time. We're still waiting. I have 12 people. I've got more to go.
Mommy, I have ice cream. Terrell's eating ice cream. Then you took it back saying I couldn't have it.
Mrs. Dale, what did you have for breakfast? I had oatmeal that Terrellyn made this morning. She is home this morning, not working. So oatmeal with raisins, had a cup of coffee. Just for something fun, my kids actually slept outside in a tent last night. So just a little bit of an adventure because sometimes an adventure is a little bit more fun. And I am dressed, obviously. Decided to go with a gray sweatshirt for the day. I'm going to mute myself for just a second and I will be right back because I need to kind of give some direction to my own children as we're getting started. So I have 14 people, so we're still waiting for a few additionals to get on. So I'm just going to mute and I'll be back in a moment.
Yeah, that's the one out of my pocket.
Okay, I am back. So it looks like some people are kind of watching together. Some people may be connecting at another time too. So hopefully we're not having a lot of technical difficulties. All right, so our class time today, we need to kind of talk again, some housekeeping things. Thank you very much for all of you who turned in your homework. I will go through and check those off and make sure that you guys have turned in everything that you needed to. Again, you are scheduled to take a test on Monday. So please go ahead and get those in the mail, snail mail, put my address on them, get them out to me next week. You do have some additional time off next week with Good Friday. So hopefully that will be nice for you guys. Additionally, you guys now know that we will not be meeting together at Grace. If this is the first time you've heard that, Grace is going to be meeting remotely for the rest of the semester. So we will continue to have class just like we are right now. our format is set up this way. So ongoing details will be going. All right. So Terrell is making faces in the background. So she is going to be skadashed out of here because she's trying to make her mother laugh. All right. So you guys all had sent out this morning a sheet with your, trying to think of my words here, with your end of the semester review and the groups that you're working in. So a lot of you chose the same chapter, so I was not able to accommodate everybody. And so what I want you guys to do is I will give you a few minutes later on to kind of try to connect with your person. You should have gotten it emailed through you through Face or through the classroom stuff. And on there, the first page talks about the format and then gives you your partner that you're working with or partners. And then the second page, as you scroll down, is all the review stuff for the semester exam. We will still be having our semester exam in May, like you would normally do. Format obviously is going to be a little bit different because you're either going to have your parents proctor it, or I'm even toying with the possibility of doing it online. I have yet to figure that out. So, but do plan you will have a semester exam. Yes, please. So did everybody, I'm looking at comments, did everybody get that sheet that was emailed out to you guys about the end of the semester projects? And if you can, I don't know if you can open it or look at it. I'm going to at least talk to you guys about that. Make sure that you have it. If you didn't get that, make sure you let me know and I will resend it differently. So the date, I think, of May 2nd is when you guys are actually going to be doing your end of the semester projects. Format will be different because no longer will you be standing in front of your classmates and actually doing this presentation. You and your partner will be doing everything electronically, digitally, and then sending it and posting it to our classroom page. So here's some ideas of what you guys can do. Looking at comments. Again, keep your comments chemistry related. Looks like everybody is saying yes. I assume that's to the question of, did you get that sheet? So you have 7 to 10 minutes to actually do a presentation about the chapter that you've been assigned, the module. Now, here are some ideas. You could actually, with your partner, do a video using YouTube and then pre-record it and then send that link and post it on our webpage or on our classroom page. You could also do using Google Slides. You guys all have a Gmail account. Hence, that's how I'm able to connect with you through Classmail or through Classroom. You have a Gmail account that you could do Google Slides and kind of go through things on that in a format that people can click through and do it. That's an option. You and your partners could decide how you're going to do that. Are you going to do half the chapter and your partner's going to do the other half of the chapter? Are you going to, one of you do the outline that's required and one of you guys work more on the presentation? Again, there's 2 parts. There's an outline, PDF, just a regular outline, and then there's some kind of a presentation, whether it be a slideshow, a video, you could do demonstration of lab stuff. However you guys want to do that, you'll have the opportunity to do that. Now, I am asking you to work together with someone, but please understand me. I do not want you to get together physically. That kind of defeats the whole purpose of being sheltered at home. So please make sure that you are using your technology to help you to be resourceful and be creative. I'm looking forward to actually seeing what you guys can do. So your video has about 7 to 10 minutes that you guys do, 8 to 10 minutes, somewhere in there, or your slideshow presentation, whatever you want to do. And then it does need to be posted by 8:30 in the morning so that everybody can look at it. That format of that class day on the 2nd will look a little different too. So I am excited about that. Okay, just kind of checking in on comments. Okay. What we're going to do is, hopefully you guys got my notes. We are actually going to do the practice problems today during our time together. So if you don't have your textbook, if you don't have paper, don't have calculator, go ahead and take a moment to get all those things, because I'm going to give you some time to read through the questions, try to kind of think it through before I work it through with you. This, I anticipate that you're going to be able to take the time to get this done during our time together, so you don't have to do this as homework outside of class time, but we'll do it together. So take a moment to go get those things. If you have your textbook in front of you, page 489 is where the practice problems are for the chapter. Does anybody have any questions over the things for the chapter? I know as we kind of go through the practice problems, we'll address probably all the different concepts of the chapter, and if we have some time, we can even go through the review questions as well, just to kind of discuss those things. So please go ahead and get those out. I'm actually going to change the camera so that you guys can actually see my book and my work as I'm going through it. So hopefully everybody's got their stuff ready, and we'll get started on the actual problems.
You know, on your paper barrel and you can flip it.
Flipping happened. Right now, I'm actually wanting to see the book, and I need to. Okay, so is that upside down for you, or is it just
No.
upside down for me?
We're
It's-
good.
Okay, so it's just upside down for me.
No, it's now upside down. You hit the button. There we go. Though it has flipped too. We're flipped. You're good.
We're good. Okay. All right. So again, we're going to start with practice problems on page 489. So I do want you to write out the answers and do the problems, and then you guys can send them to me Monday or today if you get them actually all finished, and that way I will give you credit for them. And the reason why I would like you to write them down is because that way you're actually doing them versus just potentially spacing out while I do them for you. So these, as you guys know, are good review to make sure that you guys are prepared. All right, so question number 1 says, milk sours because of a chemical reaction that takes place between some of the chemicals that make up the milk. Why does a carton of milk left on the countertop sour sooner than a carton of milk left in the refrigerator? So I'm going to give you guys a moment to think that through. All right, so hopefully you guys are remembering from what we did 2 weeks ago that temperature is one of those things that causes a change in the reaction rate. So a cooler temperature, the reaction does not go as quickly. A warmer temperature, the reaction goes more quickly. So the carton of milk that's on the countertop, of course, the temperature is going to get warmer, and then those molecules are going to interact more quickly. They're moving more quickly, and so the reaction goes more quickly. So you could write down something. I'm not going to actually write that one down. I'm going to let you guys do that, but you can explain that. I'll give you a moment. And then the next problem that we're going to do is number 2.
Can you find this book?
All right. Hopefully you guys have some things written down for number 1 about the temperature and the reaction rate. Also, just to kind of review too. So increased temperature increases the reaction rate. We also last week were discussing, or I guess 2 weeks ago. So we did some things with increased surface area. Increased surface areas because there's more places for those molecules to interact. That also increases our reaction rate. Additionally, concentration. So if you have more of those molecules with a higher concentration, the reaction is also going to go more quickly. If you have a lower concentration of reactions, then that reaction will go slower because they're kind of looking for molecules to interact with. So if there's more, if the concentration is
The auto's not working.
Krista, just let me know audio is not working. Okay. Okay. Chris, I might have to have you get off, and maybe that will make a difference. You can help monitor over here. I'm using audio stuff. Sounds demonic. That's not so great. All right, so I'm working on the audio. We're going to see if I can remove some of my family members off of technology and maybe I can stream a little bit faster. Carissa went off the computer, so she's just going to be kind of looking on with me. Okay, I'm going to continue on and we'll see if that makes any difference. If I still sound demonic, I'm not trying to. If I sound like a robot, I'm not trying to. Let me know if it gets a little bit clearer. Let's go ahead and look at number 2 though, and we're going to figure out the reaction stuff and the reaction rate with it. All right, so as we were discussing 2 weeks ago, you have to look at the trials that you've been given for this. So I'm going to kind of move this over just a little bit. All right, so looking at trial number 1, you have a concentration of nitrogen oxide and you have a concentration of oxygen. So the reaction itself,
Kaylee says you're good. They said it sounds good now.
good. All right, so looking at trial number 1 and trial number 2 and trial number 3. So comparing trial number 1 to trial number 2, the nitrogen oxide is doubled, but the concentration of oxygen stays the same. Okay. Looking then at what the instantaneous reaction rate. So if you double the concentration, does the reaction rate double or does it more than double? So as you look at that, if it was rounding it would be 0.03. So if you look, is it about 0.06 or is it more than that? And you guys should notice that from comparing trial number 1 to trial number 2, it is more than that. It is not just doubled, it is actually quadrupled. So that means you have a rate order of 2 with regard to the nitrogen oxide. All right, so we can go ahead and start writing down some information then as we are calculating this out. All right, then we need to look at the oxygen and how the oxygen concentration is affecting the reaction rate. So we are going to look and we're going to figure out which trials we should compare. So trial number 1 to trial number 2, we doubled the nitrogen oxide. From trial number 2 to trial number 3, we halved the nitrogen oxide while we doubled the oxygen. So again, that's not a great one to compare because you're having one while doubling the other. So you don't know what's actually happening. So you're going to want to compare trial number 1 and trial number 3. Trial number 1, the nitrogen oxide is staying the same, but the concentration of oxygen is doubling. Then looking at the reaction rate. For the reaction rate for 1 to 3, what is actually happening there? It is essentially doubling. So when the concentration doubles, the reaction rate doubles, that means it has a rate order of 1 for that. You could leave it blank or you could put a 1, whichever way you would like to do it. I think your textbook typically just puts a 1. All right.
Sounds back.
Being weird.
It was weird, and now it's back again.
Okay. All right. So now what we need to do is, this is the first step, but we need to now put in some concentrations to actually figure out what a rate constant is. You can choose any of the trials that you would want to and plug in those numbers for the rate reaction and for the concentrations. So I'm going to just go ahead and do trial number 1. And I'm going to put my things in. Again, I would like you guys to be doing this alongside of me. So hopefully you have your pencils and papers and are working on your stuff. And I go ahead and work and put my things in. Now I need to rearrange to get K by itself, okay? So following my work, I'm going to divide this side, and I'm going to actually show this. As the squared kind of written out. Okay. So on the right side of my equation now, I can basically cancel everything out. So if I do it on one side of the equation, of course, I need to do it on the other side of the equation. So that second is actually going to pop down to the bottom, and I'm going to divide. Now, do you need to write out the squared as written out long? No, but it helps for the units for you to keep track of things sometimes. If that's helpful, you can do it that way. Okay, so now we have K is equal to this whole thing right there. Okay. Okay, let's look at what's happening then with our units. So this molality and this molality cancel out. That second moves to the bottom. Then we have to number crunch. Okay, so hopefully you guys have your calculators handy. And I'm going to just assume that the textbook has this number written out correctly. And 1 over square root of a second for our units. Okay. So this is the rate constant for this particular reaction at this particular concentration. As you guys are learning too, that this is the instantaneous reaction rate. As the moment after this reacts, the concentration changes, which means if I calculated this reaction rate out in 30 seconds from now, that constant would be very different than it is right now. Okay. One of the questions that you guys were asked repeatedly as you were working through the things is temperature actually shown in this equation? Well, it is indirectly in the fact that this rate constant that you guys are calculating out has to do with basically the amount and the concentrations of it and how it's reacting. So yes, it does, but it's just indirect. And it's shown by the rate constant itself. All right.
Someone got 7.12 times 10 to the third. That's great.
All right. If you got 7.12
Times 10 to the third.
times 10 to the third, that is really close. It's probably depending on how you put it into your calculator. You should have three significant figures because the concentrations of the nitrogen oxide had three significant figures, etc. So show it as three significant figures. And if your calculator rounded it that way, like if you yourself rounded it, so look back and make sure that you're following your appropriate rules of rounding. But if it ends up that your calculator just gave it to you, double check, make sure you put in things correctly. But that's what the answer key gives us. All right, so that is the K, but that's actually not, okay. That's actually not the way we need to give the final answer for this. So we're going to put it back into the rate equation, which is then you're going to put the rate constant back in. All right, so that is number 2. One of the things I didn't do for you guys is give you any time to calculate this out on your own. So I'm going to do better on the next one. So looking at number 3, any questions on number 2? Chris is kind of watching my feed for questions. So if you guys have questions, let me know. Otherwise, let's go ahead and look at question number 3. And I'm going to give you guys a minute or two to actually look at it and see if you can figure out which trials we're going to need to actually compare to figure out the rate order for this. Also, if you look back at the rate overall order for number 2, the overall order, again, is the rate order for the individual things. So the overall order for number 2 would be 3. So it's the 2 plus the 1, overall order of 3.
Without rounding, I got 710.8.
710, 70.
710.8.
Okay, so that would round to 711.
Mm-hmm.
So the question, somebody posted a question. I can't even see who's posting things because Krista has the computer turned a little bit from me. So if you had 0.8,
710.8.
710.8 she's giving me, that would round to the same thing because you want it to be three significant figures. All right, I'm going to give you guys a moment or two. I'm actually put a timer on so I can keep track of. I'm going to give you 2 minutes to look at the next problem and figure out which trials you want to compare to figure out the rate order. So go. You mute me for a second.
We are unmuted.
All right, I'm unmuted again. Sorry, I should have let you know that I was going to mute, and that's why you couldn't hear me for a little bit. All right, so looking at this, hopefully you guys started looking and comparing your trials, writing out your equation. All right, so from trial 1 to trial 2, the fluorine ion is the thing that is doubled. Now, when they doubled the fluorine ion, what happened to the instantaneous reaction rate? Did it change at all? Hopefully you guys are noticing it did not. So what does that mean? That means it has a rate order of 0. You can double it, but it actually doesn't change the reaction rate. So trial 1 to trial 2 does the fluorine. And again, it has an overall, or excuse me, it has a reaction of 0. And so then we're going to go ahead and write the equation out for the rate of reaction. Now, you can put the fluorine as a 0, or you can just essentially at this point leave it off because you know it is a 0. So again, you can put it here, showing that you at least thought about it, worked on it, but again, it is 0. So as we move on, I'm going to ignore it going forward. So the next thing we need to do is look at this lovely carbon molecule and do some comparisons there. So we're going to compare trial 2 and trial 3. So the concentrations from trial 2 to trial 3 double, while the fluorine concentration stays the same. So as the concentration doubles, the instantaneous reaction rate doubles. So that means it has a rate order of 1 for it. So putting the information in for it, we need to then just be able to calculate out our K. So we're going to put in the concentration for any one of the trials we would want to do. I'm going to just do trial 1. And again, it has a rate order of 1. We figured that out because it just as the concentration of it doubles, the reaction rate doubles. Okay, this makes our algebra just a little bit easier than the previous problem to rearrange to solve for our K. So I'm going to divide this side. Okay, that cancels out on this side. So if we, of course, divide it by one side, we're going to have to divide it by the other side to show our algebra. So giving us the rate constant then. Now notice what happens with our units. The m's cancel out, leaving you with seconds in the denominator. So our units, 1 over seconds, and so this is our rate constant. Now again, this isn't the final format or the way that they would like this written out. So we need to take our R, putting in our rate constant, and putting in our order for the carbon molecule. And again, it has a rate order of 1. Again, overall order of this then is just going to be 1. So again, you can put the 1 in there or you can just leave it. But this is the correct answer then for question number 3. All right, moving on to question number 4 then. I'm going to give you guys a moment to kind of read through it. I won't mute you this time, but I'll give you a moment to read. All right, if you've read through it, go ahead and start working on it. And those people who are still processing what it is you need to do for this problem, I'm going to give you a little bit longer to kind of think through it. This one's actually a little bit different than the previous ones because they're giving you the rate order, they're giving you the concentrations, they're giving you the rate constant. You just need to figure out what the R is. You need to just calculate that out. So you're basically plugging things in. I'm going to go ahead and start working this then. It says it's second order with regard to the iodine and it's first order with respect to the bromine. So calculating that out, it gives us the rate constant. So we have R. I'm going to kind of set this up. With the format first, and then I'll actually plug in some more numbers. All right. Now, it says, what is the overall order of the reaction? Okay, the overall order basically is where you take the calculated out order for the individual reactants. So we'd have 2 plus 3. So the overall order is the first thing they're looking for as part of this question. So the overall order would be 3 because 2 plus 1 equals 3. Then it says if the reaction were run with both reactants with a 0.5 molarity concentration, what would the instantaneous reaction rate be? So basically we're going to plug in 0.5 here, square it 0.5 there, and calculate out what our R is going to be. So we're going to go ahead and do that. This, because we don't need to rearrange anything, we do need to kind of keep track of our units and what's going to happen with our units. So we have, to do that, we're going to have M and M there for our just looking at units. And here we have a squared, it's going to cancel out the squared there. So number crunching as you get, you are going to end up with All right, everybody good with that one? I'm going to move on to then number 5. Give you a moment to read through it, and did I mess my book up by touching it twice or am I quick?
You're so good.
Okay, so go ahead, take a moment, read through number 5, and let's figure out what we need to do. I'm going to put on a timer for you guys to read and calculate, think it through. So go ahead and start working it if you know what you're doing. This has to do with, I'll give you kind of some hints, that the reaction rate doubles for every 10-degree increase. But for every 10-degree decrease, then it would basically essentially halve. So think through how that you would calculate that out. What is the difference between 100 degrees and 50 degrees? And at this point, I will shush so you guys can look it through.
Taken as a question. I just have to wait for her to type it up.
All right, so kind of talking it through. So it was at 100 degrees, and the reaction then runs at 50 degrees. So for every 10-degree decrease, you have to divide by 2. So from going from 100 to 90, you're going to divide by 2. From 90 to 80, you're going to divide by 2. From 80 to 70, you're going to divide by 2. From 70 to 60, you're going to divide by 2. From 60 to 50, you're going to divide by 2. So essentially, you're going to take this, divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. Okay, what's the question? Carissa, can you read it?
When we write this out, can we say 0.0167 divided by 2 to the 5th power?
Order of operations, because you would actually do that to, I think so, right? I'm going to think that through. Order of operations say you would do that first, then do your divisor. Tell you what, I'm not going to do it both ways and see if you come up with the same answer, because order of operations does say that you would actually do your exponents first and then divide. So Tegan, I'm not 100% sure if that's you, Tegan, who's questioning, if it would give you the same answer or not. So put it in your calculator, see if it does. Otherwise, do it by the number of increments that you either increase or decrease in your temperature. Okay. The answer, though, to this, and make sure that you're putting in your calculator and getting this. I'm going to put this in scientific notation. Okay, so that should be the answer that you get. Again, Tegan, if you figure that out, I don't have a calculator even here to see it. I don't know how to use your calculator, my dear.
Mom, you can also ask if you had to write all the 2s.
She said you get the same answer both ways.
Okay, good to know.
And she also has, you have to write all the two.
You do need to show your work if that was a question. You do need to show me how many increments. So as if you're doing it to the exponent, that's fine. And if it gives you the same thing, excellent. Okay. All right, let's go ahead and look at number 6 then. I'll give you guys a moment to kind of look through that question. Krista, go ahead. I'm going to mute for just a moment.
Unmuting.
All right, so we have a difference of temperature. It says we want to increase the factor by 16. So basically you're figuring out what is the, knowing that it doubles for every 10 degrees. What is the factor that would increase the rate by 16 times? So basically it's going to be 2 times 2 times 2 times 2, which is 2 to the 4th power. So calculating that out, there would be 4 increments, or basically a change of 40 degrees for each of one of those changes. So the overall temperature then would be 65 degrees Celsius. The work that you could show on this is that, 2 times 2 times 2 times 2 gives you your factor of 16, and each increment is 10 degrees. So that means it's your 25 degrees Celsius plus your 40 degrees Celsius for each of those increments gives you 65 degrees Celsius. Okay. All right, the next number of questions are a little bit less number crunchy, a little bit more just analyzing some graphs and talking through rate constant and temperatures, etc. So looking at number 7, I want you guys to go ahead and take a couple of minutes to look through those things. I will kind of refer you back, and hopefully I'm not going to mess things up by kind of flipping back through the book, but you guys are welcome. Okay. All right. So looking back on page, okay, I'm going to just kind of move my thing. Back on page 475. Here it talks about rate of reaction changes with time, how the reaction starts very quickly, like at an exponential rate, and then decreases exponentially. I'm sure that you guys have seen all of your coronavirus exponential graphs and how those look very different with the curves. So anyway, exponential and then decreases with time, but obviously even as time goes on, we still have a slow reaction ongoing forever. Flipping this over, okay? This is concentration reaction. We kind of talked about that briefly. We said, all right, if it's more concentrated, the reaction will go quicker. Looking at the curve of this, definitely a higher sigmoid curve coming down, looking at how much higher concentration over time. And so as it decreases, the reaction rate will change. Now, temperature. Okay, looking at this, so as you have a very cold temperature, as it increases in temperature degrees Celsius, about 20, 22 is about room temperature. 30, 34 is warm, definitely, but not boiling. 100 degrees, of course, is boiling. But notice what happens again with the temperature curve on it. So then looking back at number 7, I'll give you guys a moment now that I've kind of given you the answer to that, but knowing that the rate of reaction does change with temperature, which of these graphs more appropriately shows that temperature change in a curve format? So I'll give you guys a moment to look through those. All right, this one shows that basically temperature doesn't have an effect on the rate constant at all. We know that's not true. This one shows basically as temperature increases, the rate constant decreases. Again, we know that is not true at all. Here we show basically an exponential growth of temperature. So as temperature increases, it increases greatly. Here it shows a constant increase of the constant with temperature. So the best answer then is going to be graph number 3. Okay. Looking at number 8 then. I'll give you a moment to read through it. We'll talk a little bit more about catalysts. All right, so a heterogeneous catalyst versus a homogeneous catalyst. Hetero means different, homo means the same. It has to do with the phase of the catalyst versus the phases of the reactants. So here we have that a copper is a solid versus the hydrogen and the oxygen are both gases. So this being a solid and these being both gases, we would know that this is a heterogeneous catalyst. That's all they're looking for. So again, if this was a gas, copper in a gas is not very likely, but if this were a gas and these were gases, then it would be homogeneous. So it's truly just looking at the phases of the reactants and the phase of the catalyst, and again, seeing if they're in the same phases or in different phases. Some things to remember too with catalysts. Catalysts always decrease the activation rate. They are not used up in the reaction, but they are helpful to make things go quickly. All right, so go ahead and let's look at number 9. I'll let you guys read through it. This is probably more challenging than some because your textbook really doesn't address it as much as some other things. So we'll kind of talk it through. So I'll give you guys a moment. Krista, would you mute for a moment?
Unmuting.
All right. So remembering and recalling back that this hump right here has to do with the activation energy. So what a catalyst does is it decreases the activation energy that is needed for a reaction to occur. So this particular problem has us address 3 different scenarios. One with the reaction without a catalyst, one with the reaction with a catalyst that increases the reaction rate by factor of 3, and one with the same reaction rate with a catalyst that increases the reaction rate by a factor of 10. I think the most challenging thing is by the factor of 3 and the factor of 10. Now, I will admit I'm kind of looking at the answer key to figure out which is which and trying to backtrack and figure it out. Looking at this should be obvious that this one right here is running without a catalyst. It has a very high activation energy needed, so this one is running without a catalyst. All right, so for the other 2 then, we have to look at the catalyst and the activation energy that is needed and the reaction rate coordinate that is shown. So this one has a higher activation energy than this one. This has a less of a delta H and a less of a change than this one. So one represents the catalyst that speeds it up 3 times. Okay, so less of a change, more of an activation energy. This is the one that actually has the catalyst that speeds up the reaction 10 times. So this is the one for 10 times. This is the one for 3 times. And this is the one, again, high activation energy that has no catalyst at all. All right, looking at then number 10, moving forward. All right, again, remembering and recalling that a catalyst changes the activation energy, but is not used up. So what you simply have to do, whether you have 2 steps or 3 steps, is you look at the reactants for the first step, and you look at the products for the last step. Again, whether it's 2, 3, 4 steps for the overall rate, and you see what is the same. And that will tell you what is actually acting like a catalyst. So here we have oxygen diatomic. Here we have chlorine as our products. But our reactants in the step 1, we have chlorine as a gas, and we have oxygen, which is a basically like a ozone with 3 molecules of gas together. So which one of these is the same in both the reactants in the first step and the products in the second step? And hopefully you guys are realizing that it is chlorine. All right, now, so the second part of the question is it a heterogeneous or is it a homogeneous catalyst? All right, it is a gas. The reactants itself are gases, so it would be a homogeneous catalyst. Again, homo meaning same, hetero meaning different by the Greek and Latin roots. Okay? Questions that you guys have. If you pop them on comments, I can respond back to them.
Jack wants you to repeat what you said.
Okay. Going through step 10 again, or number 10 again, a catalyst is not used up in the reaction. So you look at the reactants in step 1, you look at the products of your final step, whether again, this one has 2 steps, but your problem could have 3 steps or 4 steps. Again, you compare your reactants to your final product and see what is the same. Chlorine is the same for both the product in the final step and the reactant in the first step, so it's not used up. And then it is the same.
Does that help? I don't know, that's how I remember it.
It is the same, it's in the same phase, gas, versus both of these are gases as well. Here's the catalyst and here's the other reactant. Since they're both in the same phase, it is called a homogeneous catalyst because they're homo meaning the same phase. Does that help, Jack?
Grace says she's having trouble calculating K. I asked what problem. She hasn't responded yet, so something
Okay.
calculating K is a problem. Grace said 2 and 3.
Okay. So I'm going to kind of go back to questions 2 and 3 and seeing if we can, I'm going to flip over my book again. Chris, if I need to adjust something, let me know. All right. So the question was asked on how do we figure out the K for this? Grace, do you have a question on figuring out the rate orders or how to actually rearrange algebraically to calculate out the K? Do you have a question on figuring out the units for the final K? Give me maybe some more help on what you're having difficulty with.
She got an answer of 88.85 for K in problem 2.
Grace, do you have it basically set up the same way as I do here, showing it through? I know you were having some calculator issues with things with exponential and putting things into exponent. If you've got the same things as a setup, we really might need to figure out your calculator issues. Now, if you're not understanding how we get this as a setup, I can work you through that.
Tegan asked if we had class on Good Friday.
No, we do not have class on Good Friday. So you guys have next Friday off, which means nothing is due next week. It is due the following week, which is the 17th. So thank you to everyone who has gotten all their stuff in already because it was due at 8:30 this morning. So I haven't double checked to see if I'm missing anything from anybody. If I am missing work from you, I will let you know. I will also kind of give you guys some feedback on tests and grades as I kind of work through things since we aren't going to see each other and I don't want you to have be unaware of how you're doing on your homework and or shouldn't say your homework, as long as you're turning it in and I'm not letting you know you're not turning it tests.
Grace says she can't see your page. I have the answer book in front of me and it looks like I answered the same thing. Your page is on the screen. I don't know why she can't see. And then Jake said she didn't divide it by 0.0125 twice.
Okay. Yeah, I showed, like, if you can't see this, Grace, I'm not sure if you're just listening to the audio or whatever. This, because it has a rate order of 2, you have to divide it. This is basically showing it as 0.0125, 0.0125. Again, because it has a rate order of 2. The reason why you figure out that it has a rate order of 2 is because when you double the concentration, it quadruples the instantaneous reaction rate. So we calculated and we figured that out by comparing trial number 1 and trial number 2. That concentration doubled, but the instantaneous reaction rate quadrupled. It didn't just double, it went up 4 times or close to 4 times if it wasn't exact. So we know that it is a rate order of 2. When it is a rate order of 2, we actually have to do the concentration of it twice. And I actually showed that here in my work. And again, this has a rate order of 1 showing for the oxygen.
And she figured that was her problem.
Okay, so we're good, Grace?
Yeah. She said that Jake figured out what she did wrong.
Okay, awesome. Thanks for helping each other out.
Oh, and Kayla says she didn't get the email, but she got her question answered that Grace has been canceled for the rest of the semester.
You personally, you students didn't get emails. Your parents did from the Grace board. So If this is the first time you're hearing that, that information did go out yesterday to all of your family members. So Grace, because of COVID, has been canceled in the traditional format, but we will be continuing with class remotely, just like we are every Friday morning. Next week being the exception for Good Friday. That was never a meeting date for us. But beyond that, we will be meeting. Final exam, we will be having a final exam, yet to be determined exactly what that will look like. Whether I'm going to have your parents just proctor your final exam and mail it to me, or I'm going to do something online. So I'll figure that out by the time we get to May. I'll have that worked out. Other questions? All right, so you guys all have the person that your person or people, most groups have 2. There are some groups that have 3. You guys are going to need to coordinate with that person to start working on thinking through what you guys need to do for your final presentations. Again, those final presentations are due, I believe, May 2nd. That is outlined there by 8:30. So you're going to need to.
May 1st is the Friday, I think. May 1st is a Friday.
May 1st is a Friday. May 1st, May 2nd. I'm going to look it up. I thought it was May 2nd, but maybe I'm wrong. You will need to coordinate with your partner. It is May 1st.
Jack asked how many minutes on the presentation, how much time we have.
All right. Since you're all going to kind of do it digitally, you have about 8 to 10 minutes to do your presentations. There are 9 chapters. We meet for approximately 90 minutes, give or take. So 8 to 10 minutes. Again, if you're doing a video, that's going to be a very distinct length. If you're doing it as a slide presentation or some other format, that might ebb and flow depending on how quickly people can go through your slides and work it through. I do know that with Google Slides, you can actually do an auditory or audio portion of it too, where you actually click on the microphone. So you can talk people through your slides if you're not comfortable doing like a YouTube video or something like that. Excuse me, Zoom is also a great format for communicating with one another as you guys are even working together to work on your projects. I have chosen not to do Zoom for this class because people start to kind of talk over one another and it starts to get a little jumbly. So I'm kind of just relying on written comments while I get to hold the floor, whether I like it or not. All right, somebody else has a question. Chris is letting me know.
How do you want us to do our presentations, and how many slides do you expect us to do?
All right. How do I want you to do your presentations? Honestly, it's going to be a little bit how you and your partners come up to do it. Again, I think there's a lot of different options out there. So you work together with your partner, do some brainstorming, do some who is most comfortable doing what. Again, slideshows, kind of typical format for slide presentations is you shouldn't have so much information on one particular slide. So you should have your format a little bit bigger. So you can actually have a fair amount of slides, but less words per slide page. So I don't have a specific number or length of them. Everybody's chapter is a little bit different. You could include formulas. You could include extra practice problems on how to do those. You could include maybe even some embedded video. There's a lot of different options out there. So again, some of you are going to love this. Some of you are not going to be as comfortable. So kind of work together with your partner, kind of coming up with something that will work for the 2/3 of you as you work together. This will be graded, and your grade, as outlined in the sheet that I sent you guys, will be on your outline that you're doing. So there should be like a 1-page outline that is not a video, not as a slide, etc. As what, in addition to whatever presentation. So generally, I've been pretty generous with the grading, but there is a grade affiliated with it. Chris, a question.
Jack wants to know if we can crack jokes as long as we keep it brief
In your video, is that what you're asking?
on the slides or in our presentation, I'm assuming.
If you want to make it enjoyable, that is fine. However, make sure that it is also informational and appropriate for your fellow Christian classmates.
Outlines.
Okay. Is there a specific question with
No.
outlines? Okay. So outlines are due as a separate thing than your presentation. So again, we can talk about this a little bit more. If you don't have the contact information for the person that you are working with, please let me know and I can forward either their email or their phone number or whatever and get that to you so that you guys can start to work together. You have some time off this next week, and as I know, you're not going very many places, so you actually have some time. So I'm expecting some fabulous presentations as you guys move forward. Kyler says, I need to tell you to like and subscribe to my YouTube channel. Really not trying to be a YouTuber. All right. If there are no other questions, we will go ahead and I can mute myself if you guys want to chat for a little bit and like get together. Remember that all of these comments are public, so the world is seeing your comments. Now, not that I have really promoted myself as a YouTuber, so I'm pretty sure it's mostly Grace people. I don't know.
Kayla just sent out a hashtag saying make Mrs. Dale a famous YouTuber.
All righty.
And that is their new goal.
All right, you make me famous, guys. Fabulous. Love ya. All right, I will go ahead and mute for myself, and you guys can figure it out, and then I will close down the channel in a couple minutes for live video feed.
Tyler.
Who's putting it down?